Okay, hi everyone. In this video, I'm going to show on Gauss elimination and Gauss-Jordan elimination to solve system of linear equations. So if it's given this system of linear equations, okay, this one. So if you write in augmented form, AB x is equals to AB. Okay, this is called augmented form. So the Gauss elimination is we use ERO. So we reduce ERO until we get REF or upper triangular matrix. And for Gauss-Jordan elimination, also we use ERO, but we reduce until RREF or identity. So both this Gauss and Gauss-Jordan method, we use ERO to get the to solve the system. But for Gauss elimination, we stop at upper triangular or REF. But for Gauss-Jordan, we stop until identity. So let us take a look at the example. Okay, for this example, we want to solve it by using Gauss elimination, meaning we need to reduce the matrix until we get upper triangular matrix. Okay, first of all, let's transform this in this system in matrix form. So it's actually x equals to AB, right? So it's actually AX equals to B, sorry. So your A is the coefficient of x, y, z, 1, 1, 1, 2, negative 1, 1, negative 1, 3, negative 1. Multiply by x, y, z. So it's equals to 0, negative 1, negative 8, the B. So this is A, B, and A, X, and B. So now to solve for Gauss elimination method, we need to write in augmented matrix AB. A is 1, 1, 1, 2, negative 1, 1, negative 1, 3, negative 1. The B is 0, negative 1, negative 8. So we need to reduce A until we get upper triangular form. So remember using the ERO. I hope you still remember how to use ERO, how to perform ERO. So this one I want to make it 0 here, 0 here. So it's between R1 and R2, R1 and R3. So to get 0 for 2 is negative 2 R1. For negative 1 will be R1 plus R3. So I'll write it straight away. I do both for 2 steps at the same time. So for row 2 will be 0, negative 2, minus 1 is negative 3, negative 2 plus 1 is negative 1, 0 plus negative 1 is negative 1. And then this one we just need to plus them together, 0, 4, 0, next 0, negative 8. Okay, so our objective is we want to get the REF, whether it's REF or upper triangular. So this is not yet upper triangular, so this one we should make it 0 here and 1 here. So I write it here. Okay, we want to make it 1 here, time with negative 1 over 3 of R2. So we get the answer. So the rest will remain unchanged. Times negative 1 over 3, this one is 0, 1, 1 over 3. This one is also 1 over 3. Next is, we want to get 0 here. So the answer would be negative 4R2 plus R3. So R1 and R2 doesn't change. So 0, 0 here. Okay. Negative 4 times 1 over 3 is negative 4 over 3 plus 0 is negative 4 over 3. And then negative 4 over 3 minus 8. The answer is negative 28 over 3. So now we can stop here because it's already, we have to, it's better for you to make it 1 here, okay, to simplify it later on. So negative 3 over 4 of R3. So the answer will be 1, 1, 1, 0, 0, 1, 1 over 3, 1 over 3. Here is 0, 0, 1. Here is 7. So now it's already in upper triangular or REF form. So we can stop here. So we know that this is X, Y, Z, right? So we from here, okay, look from the third row. So it will be Z is equals to 7. And then Y plus 1 over 3Z, okay, here is equals to 1 over 3. And then here, X plus Y plus Z equals to 0. So from here, Z equals to 7. We substitute 1 in 2. So Y plus 1 over 3 times 7 is equals to 1 over 3. So Y must be equals to negative 2. And then substitute, okay, this Y and Z in 3. So we substitute X minus 2 plus 7 equals to 0. So X must be equals to 5. Negative 5, sorry. Negative 5. So this is Y, this is X, this is Z. So that's how you do it. First, you need to write in this augmented form. Okay, in this augmented form, A and B, and then you perform the ERO until you get upper triangular or REF. Okay, and then you stop, you solve the equations. You start from below or from the bottom. Z equal to 7. 1, 2, 3, and then you substitute. So you will get what is X, Y, and Z. Then it's considered solving the system, meaning we want to find what is Y, X, Y, and Z. Okay, next for Gauss-Jordan elimination. So we have the same question, but we want to solve it using Gauss-Jordan elimination. So the same thing, okay, we need to write A x equals to B. So it is actually 1, 1, 1, 2, negative 1, 1, negative 1, 3, negative 1, x, y, z is equals to 0, negative 1, negative 8. So you should start from the augmented matrix. This one, 1, 1, 1, 2, negative 1, 1, negative 1, 3, negative 1, and then 0, negative 1, negative 8. Okay, the same as I've shown in the previous example on Gauss elimination. So for here is this example, I will just continue. So just now we stop here and then we find the Gauss elimination. But for now, for Gauss Jordan, we need to continue until we get identity. So here 1, 0, 0. So here we want to get 0. So we refer negative R2 plus R1. So 0, 1, 1 over 3, 1 over 3, 0, 0, 1, 7. And then 1, 0 here. 2 over 3. 1 over 3. Okay. Next is we want to get 0 here, 0 here. So for the first, we refer row 3 and row 1, row 3, row 2. So for row 1, we should multiply by negative 2 over 3. For row 2, negative 1 over 3. So let's see what do we get. So row 3 will remain the same. Here is row 1, 1, 0, 0. So this one, negative 14 over 3 minus 1 over 3 will be negative 15 over 3, which is equals to negative 5. Next one is 0, 1, 0. And then negative 1 over 3 multiplied by 7 will be negative 7 over 3 plus 1 over 3 will be negative 6 over 3, which is negative 2. So see, you will straight away get the answer. So this is your x, y, and z. So you will get straight away x is equals to negative 5, y is equals to negative 2, and z is equals to 7. Okay, that's it. This is different. If Gauss or Gaussian elimination, you reduce the ERO until you get upper triangular. But for Gauss Jordan, you need to reduce until you get identity. So that's the difference. Both use ERO. Okay. So now this is the exercise. Please do it. Solve the system by using Gauss elimination. The second one, solve by using Gauss Jordan elimination.